Math 3, Unit 4, Section 7, or G. We're going to be talking about graphing radical equations. If you notice, and I don't know if you've noticed this before, but depending on how an equation is written, all of them can be translated and written basically with like vertex form. Okay, so let's recall back with translations. What does it mean when you add C at the end? How are you going to shift it? And then minus C is down. And then when you have plus X or plus C inside the parentheses like that, what will be?
To the left.
Very good. And then minus C will end up giving us to the right. And then remember that if you have a negative in front like that, you're going to reflect it across the and then with the negative inside the parentheses like that, it'll be about the
Y-axis.
Very good. One other thing I want to remind you guys of when you are doing your homework is that you have Desmos.com, and I showed you this back in Unit 1. But whenever you're graphing, if you want to double check your work, you can do this on your phone or from your computer, but double check that you did something correctly. Just plug it in there and you can see what's happening with the graph. I don't know if we're doing much of dilation, well, a little bit of dilations today, but if you're having a dilation, I'm sorry, I think there's a typo here, but I think it's supposed to be a f of x multiplies each value of the function by a, where a is a constant. So if you have a number in front, it makes it bigger. If you had a half, it's going to end up like, you'll see, never mind. But it'll make it kind of smaller-ish. Okay. Or shrink it down. It'll shrink it down where a whole number will make it bigger. Okay. So we're just going to go ahead and jump into this. So we're going to start by sketching the graph for each of the following functions. The first thing is that with the square root, this has a vertex, okay? And it's just like how we worked with vertexes earlier on in the year. And so what would this vertex be? -3, -1. So remember anything that's with X, and if you have something like with a root or a parentheses, it's always the opposite when it comes out. And then at the end, it's just that number. So that means I would go on here on the graph, left 3 and down 1, -1. And so basically your original function was at 0, 0, and then because of this number in here, we shifted left, and because of this number right here, we shifted down. Make sense? Okay. Now we kind of talked about root functions in that it's like half of a sideways parabola. Do you guys remember that? Kind of, sort of. Okay, so we kind of talked about just plugging in values to kind of find what's going on. Another way we can think about this is that the a value on here is 1. So we can kind of do our slope again. So from this point, we'd be going up 1, right 1, but not up 1, down 1. And if you kind of check that, if I plugged in -2 for x, -2 plus 3 is 1. -2 plus 3 would be 1, right? And then the square root of 1 is 1, and 1 minus 1 is 0. Okay? We're going to go ahead and skip down here again. So that was the x-intercept. So if you are finding the x-intercept, do you remember what we do to find it? Okay. If you're finding the x-intercept, remember that this is basically y. And we plug in 0 for y and solve for x. So let's go ahead and just do the math there. Okay, so that means I'm going to write this as 0 equals the square root of x plus 3 minus 1. And then what would I do to solve this? Good. First you want to get the root by itself, so I'd add 1 to both sides. So 1 equals root x plus 3. And then from there, how do I get rid of the root?
Square.
Good. Square both sides. So I square 1 and I square my square root. When I do that, I get 1 equals x plus 3. Because when I square a square root, the root goes away. And if you square 1, 1 times 1 is still 1. Correct?
Yep.
Okay? And then I subtract 3 to both sides, and I get negative 2 equals x. So my x-intercept is at negative 2, and I would like you to write that as an ordered pair. And so how would I write that as an ordered pair?
2, 0.
Very good. Okay, so next let's find the y-intercept. And so what would I do in order to find the y-intercept?
Make x 0.
Very good. Yeah, 0 for x. So we'd write the same equation, but this time I'm going to put y here and 0 in for x. So we have y equals the square root of 0 plus 3 minus 1. And 0 plus 3 is?
3.
So y equals the square root of 3 minus 1. Now, graphing wise, that doesn't really make any sense to me. I don't know exactly where that value is. So what should I do?
You should just, you add 1 to help.
You actually just have to plug it into your calculator. Jordan, you're gonna be okay. If you need a calculator, have them on the back wall. But in here, there is a square root key on the calculator. And if you look, it's right above the squared key. So on mine, I just do the second square root of 3. And I press equals, and it makes that number. And then I need to subtract 1. So I'm going to go minus 1. And I get, yeah, so we're going to call that 0.73. Okay? So my y-intercept is at 0, 0.73. So that means I'd go 0 and then up 0.73. It's just going to be in between 0 and 1. Okay, and then we can draw our curve. All right. So we're going to go backwards now because I asked for us to write the domain and the range. The domain is your what values?
X value.
Very good. And so I'm going to just put a D for domain. And so my domain, remember, we're looking at the x values. Okay, so where is my smallest x value? Good. And so we're going to do a bracket, and that's negative 3. And it goes all the way to what? Positive infinity. And infinity always has a parentheses. Okay, or the other way you could have written that is that x has to be greater than or equal to negative 3. So we have interval form and inequality form. Okay, so either way is good. Which way do you guys like better?
The bracket.
This one?
Yeah.
I actually like that better too. Okay, so then the range, that is my what? Or those are my y values. Okay, so I'm going to put R for range. And so ranges are up and down. So we always start with our smallest value. Try again. Look right here. Oh wait, just kidding. It is negative 1. I was just talking to myself. Yeah, thank you. So that's negative 1. And then it's going to go all the way up, and even though we can't see it, we know that it's going to keep getting bigger. And so it's going to go all the way to positive infinity. If it went on forever, it'd end up going to infinity. Okay, any questions on any of that so far? Pretty good? Okay, so then D says, what is the open interval? So again, when they're talking about intervals, they're talking about your parentheses. They're written like this, where f is increasing. So where is the function increasing? Is it ever decreasing? No. So the function, whenever you're talking about it, we're talking about the x values. And so it's increasing from negative 3 to positive infinity. Okay, and this next one, it says, where is f negative? So where is the function negative? And again, you're kind of like looking at your x values. Or where is the line? Where is it below this line? Where is it negative? Where's your graph negative? Do you see from here to here how it is below the x-axis? So that is where the function is negative. So what are those values? Yes, -3, -2.
Why'd you put -3 first? Oh, because
Smallest to largest.
okay.
Yes. Good question. Okay. What is rate of change? Anybody remember? Mm-hmm. Rate of change is the slope. Do you guys remember the slope formula? Close. Okay. So rate of change is your slope. Okay. I'm going to kind of go over here and we're going to talk about our slope formula. So remember, for finding slope, you have y2 minus y1 over x2 minus x1. And so specifically, they are wanting the rate of change from 3 to 7. And so over here, they're wanting it, this is 3, right? All the way to 3, 4, 5, 6, 7. So they're wanting to know, well, what's the slope of the line from those 2 points, okay? So how do you find it? Well, you first have to find the 2 points. And so if they're asking from 3 to 7, we need to plug in 3, get the answer, and then we need to plug in 7 and get the answer. So let's start by plugging in 3. So all you're going to do is take that and plug it into the equation, okay? So y equals the square root, and instead of writing x, I'm writing 3. So 3 plus 3 minus 1. What's 3 plus 3? 6. Square root of 6 minus 1. Now, while this is the exact answer, we want like a decimal to help us out here. And so we're going to go ahead and take out our calculators, and I'm going to find what is the square root of 6. And I press enter, and I get that number, and then I subtract 1, which is, we're going to call that 1.45. Okay? And so y equals 1.45. So this ordered pair, so one of my ordered pairs is, what value did I plug in for x? 3. And then my y value was? Okay. Now we have to find the other point. So that one I'm going to plug in 7. Okay. So y equals the square root of 7 plus 3 minus 1. So we get the square root of 10 minus 1. We're going to use our calculator. I'm sorry, square root of 10 equals that. And then I subtract 1, and so we are going to call that 2.16. So my other ordered pair is? Perfect. And so now we just have to find the average rate of change by finding the slope. And so how will I do that? Yep, so I'm going to go 2.16 minus 1.45 over 7 minus 3. So I can take my calculator, 2.16 minus 1.45, and I get 0.71 over 7 minus 3 is 4. And so when I divide that by 4, I end up with, it's 0.1775, so we would call that 0.18. So my rate of change is 0.18. This is not difficult, it's just there's steps. So, what do you want me to go back and talk about? Or do we just kind of want to recap everything that we did? So, to start off with, we wanted to graph this by shifting. And so we found that the vertex was at -3, 1, because whatever's under the root or in parentheses, you take the opposite of that value, which would be -3 and -1, and we plot that point. Then we went ahead and found our x-intercept and our y-intercept because that gave us 3 points to make it easier to graph. And so we find our x-intercept by plugging in 0, solving for, or plugging in 0 for y, solving for x, and our y by plugging in 0 for x and solving for y. So we found those 2 points. Once I had those points, I was able to go back and talk about the domain and range. So the domain is all of our x values, the range is all of our y's. And then it said, when is this interval negative? Well, it's negative when it's below the line, below the x-axis. And so this was the point from here to here is when it was below the x-axis. So that's how I got that negative value. The whole graph is increasing, so that's why I had the whole domain, because it starts here and it's increasing the whole time. Okay, and then rate of change, you just have to find 2 points and find the slope. Okay, so far so good? All right, so let's try another problem. So if you want to turn your pages over. So a couple things on this that I noticed. One thing is I feel like it's not really written in the correct form. It's not in the same order that we would normally write these in. Another thing is that it's a dilation because it has the -1/2 in front. Okay, so the first thing I'd like to do is rewrite this. So I like my x part to come first. So this is actually g of x equals, and so notice that the -1/2 root x is all together. So that's -1/2 root x, and then the 4 is plus 4. Okay, is everybody good with that? All right, so what would be my vertex here then? So under the root with the x, what's there? Nothing, right? Like there's nothing being added to the x or subtracted from the x. So therefore the x value of the vertex would be 0. Okay, good. And then it's going to be 0, 4. So we go 0 and then up 1, 2, 3, 4 to make that point. Okay, the next thing I would do is let's just go ahead and find our x-intercepts and our y-intercepts because that makes it easier to graph, and then go back and do our domain and range. So x-intercepts, what do I do?
Make g of x equal 0.
Very good. We plug in 0 for what would be g of x, or you can think of that as y. So we go 0 equals -1/2 root x plus 4. Okay, what would I do now? Good. Subtract 4 to both sides. These cancel. I have -4 equals -1/2 root x. What do I do now?
Multiply by -2.
Very good. So we multiply both sides by -2. And so I can write it right here too. If I multiply this by -2, what happens?
Get a positive 8.
Good. These all cancel out. And then on the other side, we get a positive 8. So 8 equals root x. Anybody confused by that step? Okay, now what? Square both sides. Okay, so we square the 8, we square the x, and we get 64 equals x. So as an ordered pair, what is that? 64, comma 0. Now, do we want to go all the way out to 64?
Yes.
Nah. Okay, but if you wanted to, you could mark it, right? Could we put that like right here and just call this 64?
Yeah.
Sure.
Just skip it.
What do you notice about this curve? Well, it's going long, right? But when it's sitting here, but do you notice how this one, the curve is going down?
Yeah.
Where the last one is going up. Why is that? You guys are very intelligent because of this -1/2. Okay, and remember the negative in front makes it reflect across the x-axis, right? So this is reflecting, but it's also shifted. Does that make sense? Okay. Y-intercept. How do I find the y-intercept? There, 0 for the x, good. So we have y equals 4, or I went to this equation. Does it matter if I plug it into this one or this one? No. So it doesn't matter what you do. I started that way, so I'm just going to finish it. Negative 1/2 root 0. Well, root 0 is just 0. And then negative 1/2 times 0 is 0. So we end up just getting y equals 4. And so I'd write my y-intercept as what? 0, 4. And does this make sense since I already have a point on the y-axis? Yeah. Okay. So we have our x-intercept and our y-intercepts. We can go ahead and draw our curve. But if you wanted to, because of this is kind of gives us an idea, our a value gives us an idea of how it's going. Even though it's not exact, it's going down 1, right 2. But just remember that's not perfect. And maybe it's, okay, sorry. Anyways, you guys get the idea here. If you can draw better than me, that's better. Okay, so our graph kind of looks like that. So let's talk about domain or range now. So going backwards, domain. Domain, we're looking at our x values. So what is my smallest x value?
0.
Okay, so we're going to do a bracket and 0, and it goes all the way to where? Positive infinity. Very good. Okay, and so then we're going to move on to our range. What would be my smallest range value? Negative infinity, because it's going to keep going down, right? And so my smallest range value is negative infinity, and then my largest range value is going to go up to what? 4. Because remember, the range is the y, so the largest y value is up there at 4. Okay, so when is this decreasing?
From 0.
0 to negative infinity. Or not 0 to negative infinity, 0 to infinity. And I feel like on our last example, I should have had brackets where I had some parentheses.
Yeah, I was going to ask that question.
Yeah. So we'll go back there in a second. And then the average rate of change, what do I need to do? Slope, good. And so in order to do that, we need to find,
y2 minus y1.
yeah, but in order to do y2 minus y1 over x2 minus x1, we actually have to have 2 points, right?
Yeah.
Okay, and so since it's between 0 and 16, I'm going to plug in 0 and 16. Okay, so we're just going to come up here to do all this. And so we're going to start by plugging in 0 into our equation. And so, and actually, haven't we already plugged in 0? Yeah, and so 1 point is 0, 4. So I'm just going to have to now plug in 16. So we have y equals negative 1/2 root 16 plus 4. What is the square root of 16? 4. And so we end up with negative 1/2 times 4, which is negative 2. And negative 2 plus 4 equals 2. And so my other order pair is 16, 2. Right, because we plugged in 16 for x. Okay, so now when we're finding our rate of change, what are we going to write?
2 minus 4 and 16 minus 0.
Good. And 2 minus 4 is?
Negative 2.
Good. 16 minus 0 is?
16.
And so my average rate of change is?
1, negative 1 is.
Negative 1/8. Okay, questions?
Once you reduce the 1/8 basically, use your calculator.
Could you get a decimal, you mean?
Yeah.
You could. But if it's a fraction, normally you'll see it as a fraction because rate of change is slope, and you know how slope is usually rise over run. And so if you have it as a fraction, I would leave it as a fraction. Okay, are we ready to move on? All right, now what do we know, if you notice this next one is a cubed root. What do we know about cubed roots and negative and positive numbers?
Might.
Can you have negative numbers under a cubed root?
Yes.
Oh, yeah.
Yes. And so you know how on this one, it was just half of a sideways parabola. The graph is going to be different on a cubed root because you can have negative and positive values. So something to think about there. Okay, we're going to start by go ahead and putting our vertex. So what would be the vertex on this problem?
Negative 4, 1.
Negative.
4, negative 1.
Good. Negative 4, negative 1. So we go left 4, 1, 2, 3, 4, down 1. Okay, next, let's go ahead and find our x-intercept and our y-intercept, and then we'll go back to domain and range. Okay, so x-intercept, we're going to plug in what?
0.
Good, 0 for y. So we're going to have 0 equals 2 cubed root of x plus 4 minus 1. What would we do now?
Add the 1.
Good. Add 1 to both sides. These cancel. 1 equals 2 cubed root of x plus 4. Next, what will I do? Divide by 2. So that cancels. And so I have 1/2 equals the cubed root of x plus 4. And how do I get rid of a cubed root? Yeah, you put it to the third power.
Yeah.
Okay, and so by putting it to the third power, it gets rid of that root. And so what is 1/2 to the third power? You cube both the numbers. So if you cube 1, it makes 1. If you cube 2, it makes 8. 1/8 equals x plus 4. Now, at this point, there's a couple ways of solving this. Most of you do not like fractions, so how can I eliminate the fractions? Good. So we can multiply each term by 8. You don't have to do it this way, but this might be the easiest. So these cancel. You have 1 equals 8x plus 32. And then what would you do now?
Subtract 32.
Subtract 32. And we get negative 31 equals 8x. We divide by 8, and I get x equals negative 31 over 8, but I would plug that into my calculator. Because I can't really, it's hard to picture where negative 31 over 8 is without knowing what it is as a decimal. So when you plug it in, what does it equal? Negative 3.875, and so what do we want to round that to?
Negative 8.
3.
3.8. 8.
3.9. 4 almost.
Let's do negative 3.9. Okay, and so as our x-intercept, we have negative 3.9 comma 0. And so negative 3.9, negative 1, 2, 3.9 comma 0 is like right there. Okay, y-intercept. What do I do?
Plug it in.
Which this one's going to look a lot nicer. So we're going to have 0 equals 2 root, or not 0, sorry, y. Y equals 2 root 0 plus 4 minus 1. 0 plus 4 is 4.
It's a cubed root.
Thank you. So I have y equals 2 cubed root of 4 minus 1. And so that can't be simplified further, but obviously, well, I think it's obvious, we want to change that to a decimal. Correct? Okay. So each calculator is different. So if you need me to, I can end up coming and helping you. if I know how to do the stuff in your calculator. So we will play around with this later, but I'm just going to go ahead and tell you right now that this decimal is 2.17. And so as an ordered pair, we'd write that as 0, 2.17. Bless you. And so 0 up 1, 2.17, so just past that, and there is my y-intercept point. So right now, this part goes like this. Now, and if we had Desmos open right now, I would show you. But what happens is this actually ends up going the opposite direction as well. So if you were to plug in a value negative, it ends up curving the opposite direction this way. And if we kind of use our slope, which I'm going to do, even though it's not accurate, so you know how you'd go like up 1, 2, right 1, which you can see it kind of there. You would also go down to left 1. And so this curve ends up going this direction. Okay, so there's our graph. Domain. What do you think the domain is? What are all the x values? What's the smallest x value? What's the largest x value? Very good. Negative infinity to positive infinity is correct. And the range, what's the smallest y value and the largest y value? Good. Okay, so when is, oh, go ahead.
Why did we draw another graph going backwards?
That's what happens with cube roots. So remember, with square roots, we can only have positive numbers, but with cube roots, you can have negatives and positives.
Okay.
So whenever it's a cube, it's going to be going up.
Mhm.
Okay. So you just kind of use the slope too. Okay.
Yes.
Thank you.
Okay, the open interval where h is decreasing. So where is the graph decreasing? When does it start going down instead of up?
From negative.
Yeah, so if you look at this point, it goes increasing, and then from here going backwards, it's decreasing. Do you guys see that? And so how would I write that interval?
Negative. Or no, negative infinity to 4.
Negative infinity to, is that 4? It's actually 4 is where it changes. And this, we're just going to use parentheses because when you're talking about increasing and decreasing, remember at like the point when it's not increasing and decreasing, it's basically nothing. And so at 4, it's neither increasing nor decreasing. It's where it's changing. Okay? And then it says the open interval where h is negative. So where is it below the line? So do you guys see right here at this point at our x-intercept, that is when it is negative. Yes? So we would write this, the open interval is from negative infinity, because you always start with your smallest value. So it's negative from negative infinity all the way up to which point? Where is that point? Negative 3.9. So you could write that as negative 3.9, or you could have even written that as the negative 31 over 8. Either of those answers would be correct. And in fact, going back, these parentheses back here on example 1, these were correct. And the reason is like when things are increasing, remember, oh, actually because here it's not increasing or decreasing at this point, and then it starts increasing. So remember, it's like you have it's almost like your 0 point, and then it's increasing. And so whenever you're talking about increasing and decreasing, you're going to be using your just parentheses, no brackets. Okay, any other questions?